Hello everyone, so today I will be talking about phase changes. And I am Nova Faith Santotome, the presenter. So the topics that will be included are phase transitions, phase diagrams and equilibrium, and phase change and heat latent. So phase transitions play an important theoretical and practical role in the study of heat flow. Melting or commonly called fusion, which is yung solid nagtuturn into liquid. Freezing naman ang tawag kung ang liquid turn to solid. Then if the liquid turn into gas, tawag doon ay evaporation. Kabaliktaran naman nun ay condensation kung ang gas nagtuturn into liquid. Familiar naman siguro kayo sa water cycle, di ba? So a substance melts or freezes at a temperature called its melting point and boils or condenses at its boiling point. Then ang sabi ay nakadepende yung temperature sa pressure. So kung the higher the temperature is, the melting point and boiling point ay mag-higher din. Then kung mag-low pressure naman, maglo-low din yung melting point at boiling point. So, nakadepende yung phase of a given substance sa pressure and temperature. Thus, the plots of pressure versus temperature showing the phase in each region provide considerable insight into thermal properties of substances. So, ang tawag sa phase diagram ay nag-show ng small letter p at capital letter T. So, the boiling point curve ends at a certain point. Tawag doon ay critical point. Then, a critical temperature above which the liquid and gas phases cannot be distinguished, the substance is called supercritical fluid. So, tawag naman sa pressure ng critical point ay critical pressure. So, nakikita nyo yung diagram. Ang tawag dito sa gilid banda, yan yung pressure. Then, ang tawag naman dito banda sa baba ay temperature. Yan na yung PT na sinasabi sa phase diagram. Then, sublimation yung pataas, papunta sa triple point. Then, melting naman yung papunta sa 218 na pressure. Critical naman yung sa point ng 218 na pressure at saka sa temperature ng 374. Then boiling yung galing sa triple point papunta sa critical point. Equilibrium is at the melting temperature. The solid and liquid phases are in equilibrium. If heat is added, some of the solid will melt, and if heat is removed, some of the liquid will freeze. So the situation is somewhat more complex for liquid-gas equilibrium. So vapor pressure is when the liquid in a closed container at a fixed temperature evaporates until the pressure of the gas reaches a certain value. So na-notice nyo naman yung picture, diba, na yung sa first picture, kapag equal yung combination ng temperature at saka pressure, so yung liquid tsaka gas nasa equilibrium. Then yung nasa second picture naman, mas higher yung temperature, mas faster din yung boiling rate ng water. Then we will proceed at phase change and latent heat. So far, we have discussed heat transfers that cause temperature change. However, in a phase transition, heat transfer does not cause any temperature change. So, as shown from the picture, for an example of phase changes, consider the addition of heat to a sample of ice at 20 degrees Celsius and atmospheric pressure. So the temperature of the ice rises linearly, absorbing heat at a constant rate of 2090 joules or kilogram degrees Celsius until it reaches 0 degrees Celsius. So the temperature again remains constant during this phase change while the water absorbs 2,256 kg of heat and turns into steam. So when all the liquid has become steam, the temperature rises again and absorbing heat at a rate of 2020 joules or kilogram degrees Celsius. So if we started with steam and cooled it to make it condense into liquid water and freezing to ice, the process would exactly reverse. So with the temperature again constant during each phase transition. The example picture is the glass with an iced tea. So condensation forms on this glass of iced tea because the temperature of the nearby air is reduced. So the air cannot hold as much water as it did at room temperature, so water condenses. Energy is released when the water condenses, then speeding the melting of the ice in the glass. Then another example yung sa picture, the ice on these trees release large amounts of energy when it froze, helping to prevent the temperature of the trees from dropping below 0 degrees Celsius. So the water is intentionally sprayed on or charged to help prevent hard frosts. So the energy involved in a phase change depends on the number of bonds or force pairs and their strength. So the number of bonds is proportional to the number of molecules and thus to the mass of the sample. Then heat of fusion or heat of melting, it is the energy per unit mass required to change a substance from the solid phase to the liquid phase, or release when the substance changes from liquid to solid. So heat of vaporization is the energy per unit mass required to change a substance from the liquid phase to the vapor. So we will be proceeding to calculating the phase changes. Then temperature yung sa gilid. And presenting energy naman yung sa baba. So yung line na dito banda sa baba is ice, yung paakyat is sa liquid, then yung sa pinakataas is gas. So dito banda papasok yung melting or fusion at saka freezing. Then sa taas naman yung boiling at saka condensing. Then Q is equals to N and H, which is the N is representing the amount of sample. Then yung H naman representing of heat of fusion or melting and vaporization. So we have these some problems. Yung number 3, how much heat is needed to melt 45 grams of ice at 0 degrees Celsius? Heat of fusion of water is equal to 334 joules or grams. Then the formula is Q is equals to N and H equals to 45 grams times heat of fusion of water, which is 334 joules or grams. Then i-times lang natin yan sila. So calculate natin ang 45 times 334. Then the result is 15,030. Then cancel out the G and put the J on the answer. Then the total is 15,030 joules. So that's the end of my report. I hope you've learned.